discussing what a correlation is. A correlation is known as a relationship between two sets of data. And for the purposes of today, we're going to be treating those sets of data as the X and the Y. So just so that we need to do a quick refresher of some examples, let's discuss, just based on linear relationships, which ones would have a positive correlation, a negative correlation, and no correlation. So the first one that we're going to discuss, and we're going to have an XY for each of these. So for the first example, we're going to look at the temperature outside and the ice cream sales at a local ice cream parlor. So as you can imagine, if the temperature is at 0 or below 0, you're going to have probably negative sales, meaning that no one is going to be coming to the ice cream parlor. But let's say for 0 that you have also 0 sales that day. Many ice cream parlors are probably closed when it's that cold outside. Now, as the temperature starts to increase, you're going to have those crazy people who love to have ice cream when it's cold outside, I being one of them, and maybe I'm going to go to the ice cream parlor when it is really cold. Now, as the temperature increases, they're going to have days where they are making more and more sales. Maybe there's a dip, like even though the weather is, moderate outside, maybe it's raining, and so maybe not a lot of people will go. But overall, there is a positive trend with as the weather is increasing, especially on those 100 or 100 plus degree days, people are wanting ice cream or a cold sweet treat. So you're going to have this type of relationship when it's graphed out. Now, maybe you have that one-off day where it's extremely hot outside, but for whatever reason, they were closed, or maybe they had a half day open at the ice cream parlor, so their sales are much lower. We would call this statistical point right here an outlier. So it's not necessarily needs to be considered a part of the entire set of data, but we do need to recognize it that it is outside of the normal spread of data. So when you look at this, we can tell that there is what seems to be a linear relationship amongst the data points. So we are increasing here, right? And it's this positive increasing line. And we know it's positive because we read from left to right. So we're increasing in a positive way. Now let's look at a very similar situation, but now we're going to look at the temperature outside, and we're going to look at hot chocolate sales. Now, hopefully on those ski resorts, or maybe on those cold, wintry, like festive nights with the lights where they have little hot chocolate stands, you'll see that on those cooler temperature days, lots of people are standing in line to purchase hot chocolate. But as it's getting hotter and hotter and hotter outside, people are tending to buy hot chocolate less and less. I'm not like with the ice cream where it's cold and I want it. Ice cream, I do not want hot chocolate if it's 100 degrees outside. So they're not making nearly as much. So overall, we have a negative trend, which would be a negative line. So we would call this a negative correlation. There is a relationship between the two of these. And we could even go ahead and say that this is a negative linear correlation. So here we have a positive linear correlation. And now we're going to talk about, I guess we can discuss actually two more types, but my favorite example is discussing shoe size and algebra grades. If I have students, and I teach students from 6th grade, 7th grade, 8th grade. Now, if I have a student that has a relatively small shoe size, but they're scoring really high in my class, that could be one of my 6th grade students. They're extremely advanced, they're performing well, but they have a tiny shoe. I also have some 6th graders who have relatively larger feet, and they're not doing so well in my class. I have some 7th graders. They have middle of the road type shoe size, and they're doing middle of the road in my class. I have students who are, taller than me. They're almost reaching, 6 feet tall. They have very large feet, and they're doing really, really well in my class. So what I'm trying to get at is that it doesn't matter the shoe size because it doesn't have a relationship or a tie to the algebra grade. So in this situation where you have a cluster of points, which this is actually called a cluster, okay, we can also determine that there is no correlation between shoe size and algebra grades. Now, you can check out the next video, which is going to get into finding the regression equation, which will then build off of what a correlation is.